Now I want to open this power supply and take a look inside and see what makes it tick. First, make sure to unplug it. Then you have 7 screws around the case. 3 on this side, 1 up top, and 3 on the other side. So let's get to it. The screws are of course all threaded. Let's open up the case. I think you have to lift it up in the back and then... Now I have opened it up and we can take a closer look at the internals. What's really obvious is the big transformer in here. We can actually see how this thing works. Your mains connector, it's actually nice to see they're using the fuse, because this is probably the hot wire. It is actually heat shrunk. Mains comes in, goes to the power switch where you turn it on, goes back to the selector switch for your mains voltage. It likes either 110 or 220 volts. Then it goes to the primary winding on the transformer. That's the winding down here, either 220 or 110 probably. And then up top you have the secondary windings with the 4 tabs. On this side there's some power for the control boards. The 4 tabs which come in at the side of the relays. They're down here, the blue things. Those are relays. They select which one of the tabs gets used. Then the selected tab gets rectified and fed back to the power board. And depending on how much current or voltage you selected, these power transistors dump the rest of the unneeded power into the heatsink. And then this fan pulls it out. So there is really not that much to it. I want to take out this board and take a closer look. So let's do that. It's pinched in at the bottom. Probably have to wiggle it out. Yeah. Here we go. The soldering job on this board looks a bit crusty at times. At this end also. Seems to be like hand soldered or something. Not the finest job, but what to expect. Also up top here, looks hand soldered. I don't see any thermocouple or something like that on the transformer or on this heatsink. I'm guessing this fan always runs at full tilt and it's just soldered right here at the edge of the board. So you can see how this thing works from the back of the power board. You have these 4 tabs which come from the transformer. You have the 2 relays. This is one and this is one. Each of the relays select one of the tabs for the rectifier. So this relay selects between these 2 tabs and this relay selects between these 2 tabs. And depending on which tab is selected, you have 4 different possibilities. For example, if this lower tab is selected for one side of the rectifier, then the other relay can select between these 2. And if the other one of the lower relays is selected, then you have another 2 different options between these 2, or the other way around. And these are the wires going to the rectifier. These 2 are AC and these 2 are DC. If you look at the capacitors on the other side, this is the positive side, this is the negative side. And you can see that the other one, this one is the white wire which goes straight up front white and yellow wire down here. White and yellow, those go to the terminals up front. Yellow is the positive terminal and white is the negative terminal. Blue is ground. It is connected down here to the transformer in the case. Your plus and your negative outputs. This yellow wire goes to the power transistors on the heatsink. Then it comes back. The two power transistors have different emitters. Then each of the emitters goes to one of the shunt resistors, to the big ones, white ones. Maybe you can see down here 2 of those. Each one has its own path, but interestingly enough, there is only one wire for the base of these 2 power transistors. So it goes through the shunt resistors and goes to your positive terminal up front. Then through your load and back to negative, and that's basically it. You have, of course, this is probably the low offset op amp to sense the current running through. You have down here, these are the voltage regulators, the 719, the 718. The fan is, curiously enough, upside down on the 719. This is the more negative side. This is usually the ground, and red is of course more positive than the negative -15, so this is the right way up. This is the circuitry. This is where actually the magic happens, where you select which tap to use and to regulate the voltage or current you want. So that's it. Not that much to it. It's also nice to see that the transformer is screwed down to the metal case on all 4 corners. It's really quite stable. Nothing jiggles around, which is nice. I want to have a closer look at the internals of this. I can see some Texas Instrument parts. LM324, which is of course an op amp. This is probably a power transistor. These are voltage regulators. This is a 7915, which is -15 volts, and this is a 7815, which is +15 volts. As you can see, all of the TO220 devices, like this transistor or these voltage regulators, aren't fastened down to the board, which is bad because they can vibrate off or damage one of their legs if they are mounted in this way. It's especially notable because they have mounting holes in the board to fasten them down, but they didn't use them to save money probably. So you can see this is one for the power transistor, these 2 here are for the voltage regulators, but they didn't use them, probably to save a few bucks, but in a high vibration environment this might cause an issue. Of course, during normal operation you only have the fan running in here, and the transformer might also produce a little bit of vibration, but during normal operation this isn't something to worry about. But if you use it in a high vibration environment, you might want to tie them down. This is also true for all the capacitors in here. They also aren't fastened down to the board. Everything is loose. There's no elastic shmoo in here anywhere. And this might be also a potential failure mode where one of the capacitors just vibrates off. Be aware, this power supply is not for harsh environments with strong vibrations. You can also see that this comes from the transformer. It is rectified down here, 4 diodes, some capacitors to smooth out the ripple, then the 2 voltage regulators to get symmetrical ±15 volts. Then you have op amps, a power transistor to probably drive something like the big transistors are on the heatsink. You have the relays. They're 12 amp, 250 volts AC rated, not bad. Up in here you can see the shunt resistor to measure the output current. 2 5 watt 180 milliohm resistors. I can see no digital parts on this power board. You can see the Texas Instrument logo, but whether that's actually an original part, I'm not sure. There's nothing special to it. It's all through-hole technology. Because it's proximity to the shunt resistors, I think this might be like the current op-amp, like a low offset op-amp to amplify the voltage from the shunt resistors. P07CP. I want to take a look at the power transistors down in here. What are they? 2N3055. Yeah, they're power NPN transistors. They are both used probably in parallel because they both have the same number. There are 2 screws for this board. I might take it also out when I'm at it. Those are self-tappers because it goes into the plastic. This board is the display board, and as you can see, each display, this is for current, this is for voltage, has its own driver. It's an ICL 7107, which is like this really old 2000 count AD converter with 7-segment display driver capable of 3.5 digits for these 7-segment displays. Yeah, here we go. ICL 7107. Those are really old. And you can also see these trimmers, which the manual says you can adjust the current and the voltage. But I'm not sure if you actually adjust the output of this power board, you probably just adjust the display. If you tweak this, it won't actually change the output, it just changes the number you see on the display. And it also looks like this whole board was made by somebody else and they bought it and chucked it in here because it has its own power from the transformer. It also has its own power supply down here. This is an 7805, so 5 volts for this board. There's really just the board for the trimmers to select your current and voltage, but there is nothing special to it, and I'm not gonna bother disassembling it. There are also no microcontrollers or something like that. These two are just drivers for the display, and there is nothing else in here. There are no microcontrollers, no logic level circuits. It's all analog. There's no digital circuitry in here. It's all old school. I think I'm gonna reassemble the thing and see if it still works. Let's get that going. We're done and it's back together again. Yeah, nice. Now I've got it all back together and I'm gonna plug it in and see if it still works. Let's plug it in. This is the cable. And let's turn it on. Didn't break it. Thumbs up. Now I want to take a look at my theory that these adjustment trimmers don't actually change the output, they just change the display. I got my Gossen. I'm gonna turn it on, put it into DC voltage, and let's plug it in. It says 28 volts, and The Gaussian says 28.1. So we are 1 count off. Let's go down in the range or up in the range. Yeah, that's the thing with no markings on the knobs. That's really stupid. It's annoying. Let's adjust 19. We have 19.1 again, 1 count out. Let's go to 12 volt, 12.1. Let's just adjust 12.1 on the Gaussian and then adjust it on the display. No, I touched it. These are really sensitive, as you can see. Doesn't take much. So we got 12.1 on the Gaussian. Let's adjust 12.1 on the display. As you can see, I can turn it and the output voltage doesn't change. It's just the displayed voltage that changes. 12.1, there. Let's go down the range again, see where it settles. Like 5.3, we have 5.4. 5.0. Yeah. Let's go up again. 25.5. We have 25.5. That's all right. Let's go down in the range. Let's go till we have here like exactly 5 and then adjust it. And yeah, that's good enough. It will never be better. So let's turn it until it shows 5.0. Yep, just tipped it over. I might also like to do the amperage. Let's get this in here, this in here, this one will go in here. I need to change it up. Amps. Now let's short circuit. I'm gonna down and put it to like 2.5. Let's see what it actually is. So ground to here. We have 430 milliamps on the display and 430 milliamps on the Gaussian. It's pretty much spot on, and I don't want to mess with it because it really just changes the display. There's no point in adjusting it. 4 amps, the Gaussian says 4 amps. Let's go to 5 amps. The Gaussian says 5 amps, 4.9. If you round it, that's 5. I'm okay with that. I don't need it any more precise. And you just change the display value. You don't change the output of the power supply. That's done with the knobs. So what's my overall opinion on this power supply? I have to say I quite like it. Sure, it has its weaknesses, like this stupid cables that came with it, with their cold solder joints on the alligator clips, which broke immediately off. There was really no effort required in that. And you can see on this one, it's just that little bright speck on here that was actually coated with solder. Everything else was just blobbed on, and that's rubbish. I have to repair or replace them. The mains wire is actually quite adequate. It's more than enough for this application. I really like that they used something sensible here and cheaped out on this one. I can throw this one out, I don't need it. I like this power supply, it actually works. There are a few things I don't like about it, like there are no markings on the knobs, so you don't know where the min-max is and which way you have to turn it to increase or decrease your value. That's a really stupid oversight, it's gonna be really annoying when you're using it. Another thing you can criticize is that it's quite noisy. The fan is always running at full tilt, and you can always hear the relays clicking, but I guess you have to live with it. Another thing I don't like is that the banana posts have a strange thread pitch. and that the threads look a bit gnarly on this particular example. Another thing I don't like is that the trimmers are so sensitive. You have to be quite steady and delicate to get the exact number you want. But other than that, it's okay. There's nothing major wrong with it. You have to pay attention when you're using it. Again, do not power on or off with an attached load. And be careful with inductive loads when you power it off. The big positive thing about this power supply is, of course, its price. It was only 35 euros delivered to my door, which is incredibly cheap. I probably couldn't buy all the electronic components used in the power board on this side for 35 euros. Not to think of labor or getting this case or the display. Getting a whole power supply for that is actually quite awesome. And I'm probably gonna buy another one, so I have a second channel, or I can double the voltage or get a symmetrical output like plus minus 20 volts or plus minus 30 volts, but you have to be careful with that one. It is actually on the verge of what you can handle safely. With 60 volts your skin starts to conduct quite easily. Don't try it out, I know this hurts. Yeah, thumbs up on this one. It's really cheap, but it's actually quite useful. That's it for me. See you another time. If you liked this video, give me a thumbs up. If you have questions or comments, leave them in the comment section below. And as always, see you another time. Bye.